All right, I know this has been a pretty content-heavy section, but this last thing really is just for you to listen and understand what I'm talking about, okay? We're going to talk about something called dampening. So, for example, before you freak out about this graph, let's look at this equation. It says y equals the cube root of x times sine of x. So this is when two functions are being multiplied by each other, and we want to see how they affect each other. So I know it's kind of hard to tell here, but in the green, that is the sine of x graph, okay? In the red, which again, you guys don't have this in your notes, you don't need to really write this down, that would be the cube root of x, okay? Now, what's in blue here is their product of each other, and you're noticing this little pattern that's going on here. And honestly, if we expanded this window and we zoomed out, what we would notice is that it's going to get even bigger and bigger. Sorry, now I just really messed up this page, but even bigger and bigger. And that's why it's called dampening, because as we get further away from zero, the curve will keep getting bigger. And that's what really the cube root of x is doing. So what we say is that the sine of x is dampened by the cube root of x. Okay, what do I mean by that? Well, think about this. We know that usually sine of x is bounded by -1 and 1. But as I toss in there, if I multiply everything by the cube root of x, now my sine of x is bounded by the cube root of x and negative cube root of x. Okay, so again, we say that the sine curve is bounded by the cube root of x. And again, it's called dampening because as we get further away from zero, it gets bigger and bigger and crazier. So let's look at another image here. So what you guys see here is that the cosine is in green, okay, which again, you don't have that in your notes packet. E to the x is in red, okay? And then you can see in blue their product. So again, what you notice here is that cosine is being dampened by e to the x. What do I mean by that? Well, I have negative e to the x less than or equal to e to the x times cosine of x less than or equal to e to the x. E to the x is the dampening factor, okay, when I have the product of the two. And as we get further and further away, you're going to see that these curves are going to get crazy big. Let's look at one more example. So same thing here, it's actually the same as the very first one on this page, except now we have absolute value. So instead of going underneath the x-axis, now everything's above, okay? And again, the cube root of x is the dampening factor, and so is the absolute value, okay? Again, I wouldn't expect you to graph any of this by hand. If anything, I would just expect you guys to be able to identify which graph matches with, certain graphs, which graph matches with a function. And how would you do that? Well, you could just think about it. You could also plot a few points in your head. Maybe you can kind of identify some curves that are going on, but honestly, I think it would just be best to plot points in your head. But again, you don't have to graph it, just be able to identify.